So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the topic of bearings and trigonometry with a focus on using the cosine and sine rule. Now, two topics that are heavily linked on the higher GCSE paper are bearings and trigonometry, as both involve working with angles and lengths. Now, often a question may sound and appear to be linked with bearings. However, once a diagram is drawn representing the situation, it often requires skills and knowledge in trigonometry to solve. So for example, here we have a question that reads, two ships leave port at the same time. Ship A sails on a bearing of 54 degrees for 50 kilometers, and ship B sails on a bearing of 110 degrees for 75 kilometers. What is the distance between ship A and ship B? Now, typically, if this question was for you to draw a scale drawing, you could do and then use your protractor to try and work out the angles. However, they may be requiring some form of actual accuracy to work that out, because obviously looking at sketches, if you're scaling things down, it's not going to be as accurate, but also it's, again, you're looking at to the nearest whole number. So it's really important that you're able to establish that this is going to be a trig question. Also, there's no indication in the question that says for you to do a diagram for it. So let's have a look at this. So let's start by drawing a diagram that represents this. So with bearings, what you want to do first is you always want to start with a north line. So if I just draw a north line to begin with, and let's just imagine that this point here is the port. And so I draw my north line. Now 54 degrees is going to be somewhere, draw a line, and let's say that for this, just for the sake of argument's sake, that angle there is 54 degrees. Get a chunkier pen. So we've got 54 degrees, and that distance is 50 kilometers. So then we draw ship B. So we need to draw another line, and that's at 110. So if this is 90, 110 will be somewhere around here, and it's 75 kilometers. Let me just add a bit of thickness to that line. Like so. So all of this angle here is going to just use a different color. Let's go for this green here. So this angle here is going to be 110, and that distance is 75 kilometers. And what the question is asking is that if this is where ship A is and this is where ship B is, what is the distance between the two? So what I'm going to need to do is to then draw a straight line from A to B, and if I just start by calling this X, then that is what I need to find. Now if I took that triangle, I can see a triangle in that diagram. Let me just do a little sketch of what that is. So this is where the port is, this is where ship A is, this is where B is, this length here is 50 kilometers, and this length here is 75 kilometers. Now, although this little bit of the angle is 54 degrees and all of that angle here is 110, then this angle here must be the difference, which must be 56 degrees. So this angle here is 56 degrees, and here we've got an X. So automatically you're thinking cosine rule, and the reason for that is because we got three sides and one angle where one of them is X. So what we need to do is we need to use the cosine rule to find X, in which A will equal X, B equals 50, C equals 75, and capital A equals 56 degrees. So let's just have a quick refresh on the things that you need to know when dealing with bearings and trig questions. So the first thing let's have a look at is bearings. Now with bearings, you need to key remember is that there are three rules of bearings. The first rule is that you always start from a north line. So in other words, draw a north line from any point that's mentioned. You always go in a clockwise direction, and you always give bearings as a 3-digit number. So if you had 34 degrees, that would be 034. If you had 6 degrees, that would be 006. And if you had 45.6 degrees, that would be written to the nearest whole number, which would be 46, and that therefore would be 046. Then looking at trigonometry, that's involving the cosine and the sine rule. So again, remember that these formulas will tend to be given to you in a GCSE exam, but it's important that you still know how to use it and also when to use it as well. So if you know 3 sides and 1 angle, you go for the cosine rule. And if you know the 2 sides and 2 sides, you use the sine rule, where one of those sides or angles is x. And then another question that could pop up, which again is quite rare, is asked to find the area of a triangle, or the area that's contained within those 3 points, and which then you may have to use half BC cos A, or what it's sometimes called as is half AB sine C. So in other words, as long as you've got the 2 opposite sides to the main angle, then that's going to be absolutely fine as well. And also another key thing you need to be aware of is angles on parallel lines. Now, corresponding angles are basically F angles, so they're the same. So this angle here will be the same as this angle here, and likewise this angle here is going to be the same as this angle here. Now for supplementary and co-interior, that basically these 2 angles here are all going to add up to 180 degrees, as long as the two north lines will always be parallel, because they're just from another point going in the same direction, so therefore they're always going to be parallel. So all north lines will be parallel. So just remember that if you've got a connecting line, that those 2 angles there will be supplementary, which is also known as co-interior. Also, some other questions that sort of also angle facts you need to be aware of is that angles in a triangle add up to 180, angles on a line add up to 180, and angles around a point add up to 360. And once you've sort of know all each of those particular areas and the sort of key concepts, then you're good to go when it comes to analysing a bearings and trig question. So let's have a look at some example questions. Now the key thing to note is that in a GCSE exam, often the questions will give you a diagram. However, in further maths, there may be no diagram, in which you'll get extra marks for drawing the diagram, but also in textbook questions and revision questions, there may be no diagram. And if there is no diagram, you'll get a mark for simply representing the situation in a diagram. So looking at this question, it says town B is 45 kilometers due north from town A. Town C is 38 kilometers from town A in the direction of 062 degrees. Calculate the distance of town B from town C. Now again, you could easily draw a scale diagram, but we're going to go for not doing that. So now excuse me for the, well, let's definitely do this a little bit accurate. So unfortunately, this is going to be a little bit time consuming in terms of getting this all up. So the first thing I'm going to do is I'm going to draw a north line, and I'm going to label this as point A. And the reason for that is because that is what we're looking at. Now it says that town B is 45 kilometers. Now don't worry about the scale. So that's 45 kilometers, and that is where town B is. Now town C is 38 kilometers from town A at an angle of 62 degrees. Now 62 degrees is an acute angle. So if I just imagine where 62 degrees is going to be, let's just draw that line there. And let me just label this angle as 062. And that distance is 38 kilometers. Let's just say that distance there is 38 kilometers. Now the question, and that's where town C is. So the question's asking me is, what is the distance from B to C? So it's asking me what this distance here is. So if I take that triangle out of the context of the question and just label the points, so this is A, this is B, this is C, this angle here is 62, this angle here is X, this is 45, and this is 38. So from this, I can see I've got 3 sides and 1 angle. So I'm going to be using the cosine rule. So the next thing for me to then do is label things up. So there I've labeled my parts up. So little a is X, capital A is 62 degrees, B is 45, and lowercase c is 38. So using the cosine rule, I've got x squared equals, and it's 45 squared plus 38 squared minus 2 times 45 times 38 times cos of 62 And what I then want to do is type that all into my calculator. So 45 squared plus 38 squared minus 2 times 45 times 38 times cos 62. And I get an answer of 1863.407255. Now I need to square root that. So if I square root the answer on my calculator, I get an answer of 43.2 kilometers, and that's to 1 decimal place. So moving on to question 2, it says two planes leave the airport at the same time. The first plane travels on a bearing of 040 degrees at a speed of 260 kilometers per hour. The second plane travels on a bearing of 142 degrees at a speed of 450 kilometers per hour. How far apart are they after 2 hours? Now this question is a little bit sneaky because one, they don't give us distances, instead they give us speed, but also it's looking after 2 hours. So the first thing I need to do is work out the distances traveled by the planes. So if I just write distances by each plane, and this is after 2 hours. So again, remember that distance is equal to speed times time. So here for plane A, it's going to be 260 times 2, which is 520 kilometers, and plane B is going to be 450 times 2, which is 900 kilometers. So then drawing a diagram for this, so if I just pick a random point and let's call this the airport. So I'm going to draw my north line. And looking at plane A, that leaves at a bearing of 40 degrees. So I'm just going to assume that that there is 40 degrees. This is where A is, and that is a distance of 520. So then plane B travels at a bearing of 142. So again, 142 is going to, let's just imagine that's there. So this angle here is 142. And this is where plane B is, and that has traveled for 900 kilometers. And what the question is asking is how far apart are those two planes? So if I take the triangle out of the context of the question, and this is the airport, this is plane A, this is plane B, this is 520, this is 900, and this angle here is going to be the difference between those two, which is 102. And x is what we're wanting to find. So looking at this, we've got 3 sides and 1 angle where one of them is x. So we're going to be using the cosine rule. So this is going to be my capital A, that's little a, that's b, and that's curly K. So then what we've got is got x squared equals b squared plus c squared minus 2 times b times c times cos of a. And if I type that into my calculator, which I'm going to do right now, so I get 520 squared plus 900 squared minus 2 times 520 times 900 times cos of 102. And I get an x squared value, and it's pretty big, so 127,5005.343. And if I square root that answer, I get an answer of 1129.2 kilometers, and that's to 1 decimal place. So moving on to question 3, it says two tanks start from a base in a desert. Tank A drives on a bearing of 230 degrees for 12 kilometers, and tank B drives on a bearing of 268 degrees for y kilometers. The tanks are now 33 kilometers apart. Find the distance y that tank B has driven. So let's first of all start by drawing a diagram. I'm going to do this freehand just to save a bit of time. So this is the actual base. And it says, looking at tank A, it's traveling at 230. And I'm just going to say that 230 is there. And this whole angle is 230 degrees. It then says tank B is 268. So that's going to be pretty much there, and it's traveled y kilometers, and that angle there is 268 degrees. Correct, that is 268. And it also tells us that, and that's where tank B is, and it also says they are now 33 kilometers apart. So in terms of taking the diagram out of the question, that's what we do get. And the question is asking us to find y. So if I take the triangle out of the question, just so that I can just trying to link this up with trigonometry. So this is y, this is going to be 33. This angle here, which I forgot to mark, is 12. And that's where A is, that's where tank B is, and that's where the base is. And this angle here is going to be the difference between these two angles. So that angle there is going to be 38 degrees. Now, in order to find y, now you might be thinking, oh, I can just use the cosine rule. The problem with this is the fact that I can't work out y because I don't know what the opposite angle is going to be. So what I need to do is I need to find out what this angle here is going to be. Now, if I just call this a letter, so let's just call this E. Now, the problem with this is, how am I going to work out E? I need to find E before I can find y. But what I can do instead is, if I then find this angle here, that if I knew the pink angle, I could then work out the red angle, which could then lead on to work out y. So if I just call this F, now what I'm going to do is I'm going to find F first by using the sine rule. So for this, I'm using the sine rule. I've got 12 over sine F equals, and the two opposite sides and angles I know is going to be 33 over sine 38. So sine F equals, and it's going to be 12 sine 38 divided by 33. And again, I'm skipping a lot of steps, but hopefully you can see what I've done, or eventually get to what I've done. So sine 38 over 33, and F equals, and if I type that all into my calculator, so sine 38 all divided by 33, and then inverse sine, and I get an answer of 12.9 degrees. So F is then 12.9, so I can cancel that and write 12.9. So then I can work out E is going to equal 180 minus 38 minus 12.9. So then working that out, 180 minus 38 minus 12.9 gives me an answer of 129.1 degrees. So this is what that angle there is. So I can cancel E and just call that 29.1. And then from this, I can then work out what y is by using the cosine rule. So to find y, we use the cosine rule. So here, A equals y, B equals 33, C equals 12, and capital A is going to be 129.1 degrees. So looking at this, I get y squared equals 33 squared plus 12 squared minus 2 times 33 times 12 times cos of 129.1. So y squared equals, and let's just quickly type that into my calculator. In which I get an answer of 1732.495239. So y equals the square root of that, which is 41.6, and that's kilometers to 1 decimal place. And there we go. Moving on to question 4, it says that find the angle between the clock hands of 8:05. So if you imagine we've got a clock which is poorly drawn, and let's just start by marking the points. That's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so 8:05 would look with one hand at 8 and one hand at 1. Now you might find that will be some deviation with regards to, there might be slightly past certain numbers, but let's just, for argument's sake, that is not the case. So let me just draw those hands again. So minute hand is at 1, hour hand is there. So what the question is asking us to find this angle here. So first things first, let's work out what this angle here is. So at 1, the angle is going to be, well, each part of the circle is split up into 12 sections. So we're looking at 1/12 times the total number of angles, which is 360. Now, if I do 360 divided by 12, it gives me the same answer. So that angle there is 30 degrees. And then at 8 o'clock, at 8, that's 8/12 times 360, which is going to be 8/12 times 360, gives me an answer of 240 degrees. So the angle between is going to be 240, I've written 8 there, so it's going to be 240 minus 30, so the angle then is going to be 210. The next question then says for B, it says if the minute hand is 10 centimeters long and the hour hand is 8 centimeters long, how far are the tips of the hands at this time? So let's just do a little diagram. So that's where it is at 1, and that's 10 centimeters. And then we've got the hour hand, which is 8 centimeters. And what the question's asking is how far apart are this here. So that's X. Now, if this angle here is 210, then this angle here must be 360 minus 210, which gives us 150 degrees. So taking that triangle out of context, what I've got is this angle here, which is 150. This is my X. This is 10. Well, that should be 10. I don't know why. Sorry if it has confused you. So this length here should be 10. And this length here is 8. So we're again going to use the cosine rule. So x squared equals 10 squared plus 8 squared minus 2 times 10 times 8 times cos 150. So x squared equals, and if I just quickly type that in, 2 times 10 times 8 times cos 150. And that gives me an x squared value of 302.56406, blah, blah, blah. And I want to square root that answer. So I get an answer of 17.4 centimeters, and that's to 1 decimal place. Moving on to question 5, it says that port B is 25 kilometers northeast from port A. The lighthouse is 6 kilometers from B on a bearing of 255 degrees from B. Calculate the distance from A to L. So let's have a look at what this diagram would look like. So if I start by drawing a north line, and we will call this point here port A, and it says that the lighthouse is, well, port B, sorry, is 25 kilometers on a bearing of northeast. So northeast is going to be there. So northeast is 045 degrees. And let's just call this B. And that distance there is 25 kilometers. So the next thing it says, the lighthouse from B, so let's draw another north line, is 255. Now 255 is probably going to be around there. So this angle here, I'll just highlight it in red, is 255. I don't know why I've wrote 255 degrees, and is 6 kilometers. And so this point here is where L is. Draw a line, and the question's asking, what is the distance from A to L? So let's have a look at how we go about working this out. So for this, I'm not going to draw another triangle just yet because I'm going to have to deal with some back bearings. So looking at this here, this angle here is going to be 45. And this angle here is, let's use different colors. So this angle here is 180. And so to work out what this angle here is going to be, well, that angle is going to be 255 minus 45 minus 180. And if I type that into my calculator, 255 minus 45 minus 180, I get an angle of 30 degrees. So this angle here is 30, and that's what it's asking me to work out. So if I take that triangle out of context, and again, let me just start by trying to draw it slightly accurately, and then label the points. That's A, that's L, that's B. This angle here is 30. This is the distance I'm trying to find. This distance here is 6, and this is 25. So looking at part A, we've got, so looking at A, we've got x squared equals 6 squared plus 25 squared minus 2 times 6 times 25 times cos 30. So x squared equals, so 36 plus 25 squared minus 2 times 6 times 25 times cos 30, and that gives me an answer of 401.1923 blah blah blah. And so x equals the square root of that answer, which is 20.0 kilometers to 1 decimal place. So B then says calculate to the nearest degree the bearing of L from A. So what we're looking for, the question's asking us for the next part is what colour have we not used? Let's go for purple. The next question for B is working out this purple angle here. So again, looking at B, if I take the triangle out, I know that this side here is 6, this side here is 25. I know this side now is 20. This angle here is 30, and the question's asking me to find this angle here. And let's just call that y. So then what I need to do is use the sine rule to work this out. So I get 6 over sine y equals, and then it's going to be 20 over sine 30. So then sine y equals, and it's going to be 6 sine 30. Again, I've jumped a couple of steps, divided by 20. So then inverse sine of that answer is going to equal y. So y equals 8.6, which rounded up gives us 9 degrees. Now that's what the purple angle asked for, but the question is asking for the bearing from L to A. So the bearing of A to L is this angle here, and what we've worked out is that this part here is 9 degrees. Now if all of that angle there is 45 degrees, then the bearing of this is therefore going to be, so all of that is 45 from A to B. This bit here is 9, then this angle here, and again apologies for the colour, that angle there is going to be 45 minus 9, which gives us an angle of 36 degrees. So it's 036, and there is our final answer. So moving on to our last example, it says the sketch shows the flight paths between 3 airports at Appleton A, Berriton B and Cheriton C. Berriton is 90 kilometers from Appleton on a bearing of 052 degrees. Cheriton is 110 kilometers from Appleton on a bearing of 165 degrees. And part A, and let's work out these separate bits. So let's start by just checking the labeling of this diagram. So here it says that Appleton A, B and C, Berriton is 90 kilometers from Appleton. So this distance here is 90. It then says that, and that's 52 degrees, which is already on the diagram. The next one says that Cheriton from Appleton is on a bearing of 165. So this purple angle is 165 and is on a distance of 110 kilometers. And the first question is asking us to work out angle BAC. So BAC is this angle here. So for AI, it's going to be 165 minus 52, which gives us an answer of 113 degrees. Again, just make sure that's a 3-digit number. So there we go. Next question then says work out the distance from Berriton to Cheriton. So Berriton to Cheriton is this angle here. So taking the drawing another triangle and calling this A, B, and C. So we know that this angle here is 113, this is 90, this is 110, and this is what I've been asked to find. So x squared equals 90 squared plus 110 squared minus 2 times 90 times 110 times cos of 113. So if I type that into my calculator now, I get 90 squared plus 110 squared minus 2 times 90 times 110 times cos 113, and I get an answer of 27936.47634. So x equals the square root of that answer, which is 167.1 kilometers, and that's to 1 decimal place. Next question then says, by finding ACB, find the bearing of Brereton to Cheriton. So Cheriton is here, and what the question's asking me to do is to find this angle here. Now it says by finding angle ACB, so what it's asking me to do is to find this whole angle here. So to find that out, I'm going to need to use the cosine rule. The sine rule. So that angle there is going to be 90. And if I just call this angle y, so equals sine y equals, now I know what x is, so that's going to be 167.1 over the angle, which I now know is 113. So sine y equals, and it's going to be 90 sine 113 divided by 167.1. And so y equals the inverse sine of the answer to that. So if I type that into my calculator now, the inverse sine using the fraction button, and I get an answer of 29.7. Now going back to the diagram's asking me to work out the bearing of Brereton to Cheriton, which is this green angle here. And let me just emphasize that angle there, which is what I'm trying to find. And what we found is that that blue angle there is 29.7 degrees. So if I extend this line here, now this angle here is going to be corresponding to that purple angle, and that angle there is 165. So then to work out this little blue bit, that's going to be 180 minus 65, which equals 15. So if I rounded y to 30 degrees, and this angle here is 15 degrees, then that means that this green little angle has got to be 15 degrees from doing 30 minus 15. So therefore then, what we then can do is that that's going to be 0, 15 degrees as a bearing. So then moving on to question B, let me just scroll down to give me a bit of space. So let's just, the question is asking me to work out the area of the land enclosed by the flight path. So for B, if I take this diagram here, so let's just redraw that triangle. This is 113, this is 90, that's 110, this is whatever. So then what I'm going to do is to work out the area of the triangle. Well, the area is equal to a half AB sine C. So if I call the angle capital C, these two sides are going to be A and B. So the area is going to be a half times 90 times 110 times sine of 113. Just correct that. And so typing that all into my calculator, I get 0.5 times 90 times 110 times sine 113, and I get an area of 4556.5, and because the lengths are given in kilometers, that's going to be kilometer squared, and that's to 1 decimal place.